so we've got a review. So also, I'm making a video for each class. This will be the third video that I put up on YouTube. And since each class we're reviewing, people ask different questions. Some of the questions and topics we talked about are a little bit different. I think I'll put them all up on that YouTube, so that way you guys can all go back and watch them if you want to see any of the different problems we've done. So, question we had was essentially things to memorize. So this was kind of like the reference sheet that we've been drawing. Let's put everything on there now that you're going to want to know. So, two triangles, the reference triangles. Hopefully you guys got that down by now. If it helps, some people like to just know the unit circle and like have all those values filled in. I don't think that's a good way to do it. I think one of the LAs recommended it. I personally don't like that method just because it's a bigger thing to memorize. There's a lot more going on. In the past when we were in person, we would give you a blank unit circle so you could fill it out yourself, but you would still have to memorize it. Again, I'm a fan of the memorize as little possible, the most simple things possible, to then figure out everything else we need to. So these things are good to know. Our reference triangles and our sine chart. Law of sines. You're going to want to know. So that's if we have, let's write it as sine A over A equals sine B over B equals sine C over C. That's for any general triangle. Should understand how the labeling scheme goes as well, right? Again, the side and vertex with the same letter are always opposite, just different case. Law of cosines. Remember, it's just start with the Pythagorean theorem and then minus the correction term. Where on opposite sides of the equation, we have the side and the angle. And then, so since it's a squared plus b squared, the AB goes there, minus 2AB. And you can permute those variables around however you like. So make sure you know those. What else? So any of the basic ones, the Pythagorean theorem, so for right triangles, so cosine squared minus, or excuse me, cosine squared plus sine squared x equals 1. All the ones that are derived from that too. So tangent squared x plus 1, secant squared, cotangent squared x plus 1 is cosecant squared x. And then the even odd identities, you should know. So sine is odd. cosine is even. I think that's it. So the double angle will give you, the half angle formulas will give you. The sum and difference formulas are on there, but we haven't gotten to that yet. You'll do the sum and difference formulas. I think you'll start them tomorrow in the Teamwork Tuesday, and then we'll talk about them on Monday of next week. The cofunction identities are actually listed on this sheet as well, so we'll give you those. So that is trig. Some other things you may want to write down for logarithms. Remember that the definition of a logarithm is the inverse of an exponential. So these two statements are equivalent. We have the product to sum formula. Product inside the logs. The sum outside of logs. Quotient inside the log. The difference outside of the logs. And then likewise an exponential, or an exponent inside the logs, turns into multiplication outside the logs. Should also remember that log base b of x is x, and likewise b to the log base b of x is x. Logs and exponents are inverse operations. They undo each other. So whatever argument I put in here, I apply a log, then we exponentiate it. Those undo, and we get back the original number we input. Let's see. Anything else with that? Of course, if we don't write the base, log base 10, ln means natural log base e. I'm trying to think. I think that's basically it for logs, just in terms of the formulas. Yeah. So things you should memorize from that. Probably about it. And then I would say just make sure you're studying all the other, how to use all this stuff. Things like domain and range. Maybe we can write that one down. So the domain of a log is 0 to infinity. Range, minus infinity to infinity. And I think that's about it. So where do you guys want to start? What type of problems do you guys want to look at? What are you guys struggling with?
Can we do some on like trig identities?
Trig identities. Simplifying trig identities. So we had one on the IC that we didn't get to. Verify cosine of 2 theta is 2 minus secant squared theta over secant squared theta. So this is one of those weird ones where it's almost better to start with the right and then work towards the left. Because the right side is more complicated than the left. It's kind of hard to take an identity, start with something simple, and then make it more complicated. Of course, one thing we want to recognize, the immediate thing we want to recognize is that this one has an argument of 2 theta. So we have to use the double angle identities somewhere. We're going to want to use double angle identities, and then we'll probably have to use trig identities, the Pythagorean identities, to get it in this form, or vice versa. So let's actually start with the right side. Again, because it's more complicated, usually more complicated expressions should have some immediate things that we can at least do to simplify. Where the simple expression, we have to make it more complicated and then kind of guess and check of where to go a little bit more at least. So first thing we may want to do something like this. We have a difference in the numerator, which is kind of nice because I can actually write this as 2 over secant squared minus secant squared over itself. And in that case, it'll simplify. So this right term is just 1. And then 2 divided by secant squared is 2 times cosine squared. So since secant is 1 over cosine, now we get 2 cosine squared minus 1. That is the identity for cosine of 2 theta. That is the double angle formula there. Other questions? We're going to do more trig, more logs.
Can we do like some solving triangles?
Solve a triangle? Sure.
Yeah, with like using like the laws of like sine and cosine.
Law of sines and cosine? Sure. So let's have, let's see. Say this is 30 degrees. Let's say this one's 45 degrees. So that makes angle B 105. Then let's see, just put some side lengths. Let's see how many do we need. Let's say we've got 10 and then 5. Let's say 7 for that piece. And we'll make it 8 since it's not coprime.
How are you getting those numbers?
I'm just making them up. So this may or may not
Okay.
work out. And yeah. I think that'll work out. Here, we need one more angle. Let's make this angle 45 degrees as well. We'll see if this triangle works out. So let's try to solve everything. Let's solve for every side. And we've got multiple triangles in here to do. So first thing we're going to want to find is BD. So relative to the sides given, since I'm not given this full side length, it's going to be hard to work with this bigger outer triangle. So let's work with this inside triangle where I have 2 sides and an angle. So in particular, we're given side, angle, side for triangle ABD. So when we're given side, angle, side, we should use law of cosines. So let's label the sides. Let's call this one A. Let's call this one A prime. And then let's just call this side B here that we want to find. So how do we find A? We use the law of cosines, and the A and the angle need to be opposite. So we'll start with A squared on the left, and that's going to be equal to Pythagorean theorem, 10 squared plus 8 squared. So sum of squares of the other 2 sides minus the correction term. So 2 times the product of the sides times cosine of the angle. So when we find A, we're going to get 100 plus 64 minus 160. Cosine of 30 degrees is square root of 3 over 2. And so our A squared is going to be 164 minus 80 square root of 3. And unfortunately, there's not much simplification we can do. So we'll have to take a square root of both sides. And we'll get something to that effect. Now the angles we can actually solve for, because I have 45 degrees and 30 degrees, it's 75 degrees. So angle B That full angle is 105. And I guess to be a little more specific, angle ABC is 105 degrees. So A to B to C. So then what is angle DBC? So now
90.
Yeah, it's actually going to be a 90-degree angle because I have a 45-45 triangle in there. So angle DBC is 90. And because these two angles are the same, the two side lengths are also going to be the same. So A and A prime are actually going to be the same length. And then the last things we need to pick out, so since we have A and A prime, we need to find B, and then we need to find this angle here, and then this little angle there. Let's do the angles first, since those are fairly straightforward. So angle BDA should be 180 minus 45, so 135. And then angle ABD, we have 135 and 30 is 165. So that angle has to be 15. And so now our last step is actually to find B. So to find B, we could use law of sines, law of cosines, since we know side length A, or we could simply use ratios of similar triangles. So remember that in a 45, 45, 90 triangle, side lengths are in the ratio of 1, 1 to square root of 2, meaning B is equal to A times square root of 2. Which is going to look like a messy expression. So it's going to be square root of 2 times square root of 164 minus 80 square root of 3. And so we could multiply the square root of 2 under there. We could factor out the square root of 2. These numbers factor a little bit better if we wanted to make that a little nicer. Let's go through that real quick, just because working with square roots is always a little bit of a hiccup for a lot of people. So 80 we can factor out, at least powers of 4. Maybe we should factor those real quick. So 80 is 4 times 20, which is 4 times 5. So 80, 16 times 5. 16 is a nice perfect square. What do we do for 164? It's 100 plus 64. That's 25 times 4 plus 4 times 16. Here, so we can write it as 100 plus 64, which is going to be 4 times 25 plus 4 times 16. So it's going to be 4 times 41 is 164. So we can, it looks like we can at most pull out one factor of 4 from that guy. And I don't know if that'll simplify it much. So 164 is 4 times 41 minus 20 square root of 3. And unfortunately, because that one's odd, there's not an extra factor of 2 to cancel with that guy. I was hoping to get an extra power of 2 to get rid of that square root. So unfortunately, it's not. So it's going to be 2 square root of 2. It's 41 minus 20 square root of 3. And then you're going to want to distribute that 2 into the square root just to simplify those two. So it's about as nice as we can get it. Something like that. The numbers, since I kind of just made them up off the top of my head, aren't the nicest. But something that complicated won't be on the quiz. It'll be more like a basic one. So let's do one more. Let's use one where we need to use the law of sines and cosines.
Can you really quickly in between these write out or just let us know which like sine or sine equals sine and which one we use law of cosines with and which ones we use law of sines with?
Sure. Yeah, let's put that on the reference sheet actually. Let's go back. Things to memorize. So we wrote the law of sines. Use for. Law of sines is good for angle, angle, side, or angle, side, angle, 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 side. Essentially, anytime you're given two angles and a side, law of sines is going to work very well. Let's see, what other cases are there? Side, side, angle. And let's put a star next to that one. Remember, the side, side, angle ones are the ones with two possible solutions sometimes. Sometimes one solution, sometimes two, sometimes 0. Law of cosines we want to use for side, angle, side, and side, side, side. So I'm trying to think of one a little bit better. It's kind of hard to try to get it to work out. So the numbers we want to use, we want you guys to be able to compute them. But it's hard, right? Because we only know essentially 3 reference angles that we can compute easily. So let me think. So we've got 30, 60, 90, 45. Let's do. So we've got a triangle. Let's say one angle is 105. Let's say the other angle is 45. And this angle is 30. So I mean, I guess I just filled in that angle. Can always find the third angle. I want to give you 2 angles, and then of course the third one you can solve for. So I did 45 and 105 is 150. So that makes that one 30 degrees. So let's pretend I didn't give you that yet. And then let's do one side. So which side do we want? If I give you 2 angles, doesn't matter which side. We want to use law of cosine. So let's see. Let's give this side as 12. Oops, sorry, I off the video there. So if I give you these two angles, we're given angle, angle, side. If If you're given two angles, though, you might as well first step find the third one. We may not need it. We could need it. Depends on what the question asks. But if the question is something like solve the triangle, well, we need to find everything anyway. So we might as well find everything. That would B. This one's A. If it just asks for one specific side, like if it just says find B or find A, then maybe we need that angle, maybe we don't, depending on whether it's opposite the side we care about. So we can set all of this up with law of sines. So the thing we're going to know, since we have side C and angle C, we are going to have sine of 105 over 12 is equal to sine 45, that's angle A, divided by side A, which is also going to be equal to sine of 30 degrees over B. So there's two equations there. We kind of condensed them. The first thing you're going to want to do with something like this is stick with the things you know, the side and the angle that are opposite each other that you know. Compute that first. This one's actually going to be a little bit hard. Maybe we go through it. We've got 10 minutes. I think we'll be able to have the time for it. It'll help us review how the hell do we compute sine of 105 degrees. It's actually not a nice angle. Right? What's the reference angle for 105 is like a 75 degree angle. So tomorrow you'll learn the sum and difference formulas, which will be pretty useful for that. Otherwise, we can't use, let's try to do it without sum and difference formulas. I think that'll be a little quicker, but unfortunately, since it won't be on the quiz, the only other tools we can use to compute something like that are the double and half angle identities. So let's pull it out.
Is an angle like this going to be on the quiz?
Not in the same question. You will have to use double angle identities and half angle identities, but we won't put one with like both of these in there. So how do we compute sine of 105? It's going to be sine. If it's an angle you don't like, double it and see if it's an angle you do like. So what's double 105? 210. And we like 210. 210 is right here with a 30-degree reference angle. So I can compute sine of 210. Pull up your law of sines and cosines, or your double angle formulas. So those will be given to you. The half angle formula for sine, remember, was plus or minus 1 minus cosine of 210 all over 2. So it'll be plus or minus square root of cosine of 210 is going to give me negative square root of 3 over 2. And all of that over 2. So let's just multiply by a half. Distribute. Find a common denominator. And then simplify. Yeah. Now, plus or minus, do we need it? Which one do we want? Where was the original angle? 105, which is like somewhere here. and we want sine of 105, and sine should be positive in the second quadrant. So that's our answer. That might be a different question, you know, compute sine of 105 or something like that. If we saw it in this kind of context, now we can use that computation for our law of sines. So we had sine of 105 over 12 is going to be this guy divided by 12. And now we want to use this to set that equal to the other sine ratios. So we had sine of 45 over A. So you can cross multiply. A times square root of 2 plus square root of 3. Square root of 2 plus square root of 3 is 24. What is sine of 45? Write it as 1 over square root of 2, or square root of 2 over 2. Let's write it as 1 over square root of 2. Now divide by this guy. So square root of 2 times square root of 2 plus square root of 3. And then how do we simplify that? We can bring in that 2 under that square root and distribute it. So I will warn you, some of these square roots do get a little tricky, and some of them could be a little tricky on the quiz. The last one, so we do B the same way. We start with our common ratio, square root of 2 plus square root of 3 over 24 was now sine of 30 degrees over B. Cross multiply again. Compute sine of 30. So sine of 30 is 1/2. So a little bit nicer there. And then we divide by that square root term. Any questions?